Hello everyone, welcome back to my YouTube channel Maths Beyond Basics. I am Ritu R. Bendre, today discussing on the topic of conic section. So, throughout this video in 15-20 minutes we will be clarifying this following topics. We will be constructing the definition of conic section, then we will see what are circles, parabola, ellipse and hyperbola. So, now let us start with the definition of conic section. Here we need to concentrate on 2 points. The one will be directrix and another one will be focus. These both are fixed, that is the point is fixed, the fixed point is called as focus and the fixed line is called as directrix. I am saying it again, the fixed point is called as focus, which I am denoting it as F, and the fixed line is called as directrix, which I am denoting it as L. So, what happens in conic section is, we will consider a point, let us say O1, and I will join this O1 to F, that is the distance from the point to focus, and also I will be joining the point A1 and O1, that is the distance from point to directrix. So, what I have done, I am considering the point O1, I am joining this O1 to the focus, that is fixed point, a point joining to fixed point and a point joining to the fixed line, clear? And also consider another point, say O2, do the same, join the fixed point to this O2 and fixed line to this O2. Similarly, O3, fixed point to this O3 and fixed line to this O3. Now, what does the definition of conic section says is, when we will be considering the ratio of the distance between the fixed point to the focus, that is the point to the focus and the point to the fixed line, the ratio of the fixed point to the point and fixed line to the point will be equals to the same thing, that is O2F to O2A2, that I am writing here, that is FO1 divided by O1A1 should be equals to FO2 divided by O2A2, and the same thing will follow to all the other points, that is FO3 divided by O3A3, and all these ratios should be equals to some constant. That is what the definition of conic section says, that is the fixed point distance and the fixed line distance ratio should be equals to the same constant, and this constant is named as eccentricity. I hope this is clear to you. This distance from the point to focus divided by distance from point to directrix is called as eccentricity, which will be denoting by E, small e. Okay. So, now this is the definition of conic section, and this will follow all other definitions for circle, parabola, ellipse and hyperbola. Now, if the eccentricity is equals to 0, then we will get circles, and if the eccentricity is equals to 1, then we will get parabola. If the eccentricity is less than 1, then we will get ellipse, and if eccentricity is greater than 1, then we will get hyperbola. So, this eccentricity, this ratio decides what kind of conic section we will be getting. Let us see in next video. So, now let us discuss about circles. As I said, the eccentricity will decide what shape we will be getting. For circles, like discussed, the eccentricity should be equals to 0. Now, what was focus? The fixed point was called as focus. What happens in circles is, this fixed point, that is focus, will collide with center, and hence the center and focus both are same here. That is first thing that you need to know, that is the focus and center of the circle both collides. So, the focus will be same as the center of the circle, clear. Next, the fixed line that I said as directrix is at infinity, that is the main thing. The fixed line was called as directrix. So, now here in this diagram you can see that the focus is present, that is center, clear. Now, we need to see where the directrix is placed, because we also need to see that where this directrix has been placed. Now, the main thing in circles is that the directrix is at infinity, that is why the eccentricity is getting 0. See here, what was eccentricity? It was the distance from a point to a fixed point and a distance between point to a fixed line. The fixed line is at infinity. If the fixed line is at infinity, then the denominator will become infinity, because the distance is also infinity, clear. And now let us say this O1 is any point. The distance from this O1 to F is called as radius, and hence in numerator we will have radius, and the denominator is infinity because this O1 to the directrix is at infinite. Therefore, the distance is infinite in the denominator, and hence we will get the eccentricity as 0. Clear? That is why we will be getting the eccentricity as 0, because the denominator is infinity. And why the denominator is at infinity? Because the directrix is at infinity. Clear? And now in circles what happens is, as considered this point O1, I will join it with this fixed point, and that is called as radius. And if you consider any other points in plane, it should be equidistant from this F, clear. And if I consider any other point, let us say O3, it should be again equidistant from this F. So all these equidistant points together will give us circle. Now when we join all these points that are equidistant from this fixed point or center, then we will obtain a circle. That is how we will get a circle, clear. Now when we join all these points in plane such that they are equidistant from this focus, will give us a circle, clear. And hence this radius is always same to any point in the circle, clear. Now let us go to the next, that is standard equation of circle. To obtain the standard equation of circle, we will always need 2 points, that is we should always know the information of 2 points, that is one, we should always know the center, and the other thing is we should always know the radius. If these are the given data, then we can write the equation of circle very easily. Now first let us see how the standard equation of circles has been constructed. Now let us consider one circle whose center is at O and its coordinates are h, k. And let us consider any random point, say P, on circle whose coordinates are x, y. Now since this is a center and this is point on a circle, this is called as radius and it is equidistant to any other point, say Q. It is equidistant, that is from O to Q also the distance is r, clear. Now let us come to this point. Now the distance between these 2 points OP is given by the distance formula. We very well know how to write the distance formula. So what does it say? That is OP, the distance formula says that is equals to r is square root of x minus h whole square plus y minus k whole square. That is what the distance formula is. And now let us square on both sides. When we square on both sides, then we will get r square is equals to x minus h whole square plus y minus k whole square. And this is the standard equation of circle. So to write the standard equation of circle, we should be given 2 data. One will be the center and another will be the radius. Our next discussion will be on parabola. So let us discuss what parabola is. For parabola, as discussed, this focus to the point and this point to the directrix, let us say A1, should be such that this O1F divided by O1A1 should be equals to FO2 divided by O2A2 and FO3 divided by O3A3 and so on, and they all should be equal, and this all ratio is said to be eccentricity. And when will we obtain parabola? When this eccentricity is equals to 1, right? When eccentricity is equals to 1, we will get our parabola. Now this eccentricity to become 1, just analyze what will happen here. The distance between the point to focus should be equals to point to line, right? When these both distances are equal, then only the ratio will be equals to 1, clear. So therefore when this O1F is equals to O1A1, then the ratio will be equals to 1, and same O2F should be equals to O2A2 and O3F should be equals to O3A3, clear. So the condition for parabola is what? The distance between this point to focus is equals to the distance between point to directrix. Only then we will get the eccentricity as equals to 1. That will be the geometrical condition for parabola. I hope this is clear. And next we will be discussing some standard definitions of parabola, which goes as axis of parabola. So what is axis of parabola? It is a line which is perpendicular to directrix and passes through focus. So what is axis of parabola? It is a line which is perpendicular to the directrix and passes through focus. That such line is called as axis of parabola. And next is vertex. What is vertex of parabola? Vertex of parabola is, now let us just consider the parabola, that is I am joining all such points in plane which will be satisfying the condition of the ratio, that is this O1F will be equals to O1A1, this O2F is equals to O2A2, all such points in plane when considered is giving me the diagram of parabola, clear. And now as discussed the vertex, what was vertex? Vertex was the point which cuts the conic section, clear. It is a point which cuts the conic section in the axis of parabola, clear. So what is vertex? It is the intersection of the axis and the conic section, okay. It is the intersection of the axis and the conic section. That such point is called as vertex. And here in our case O4 is vertex. Okay. And next is double ordinate. So what is double ordinate? It is any line that passes through the focus. Okay. It is any line that passes through the focus. Let us consider this line. So this is a double ordinate. It is a conic, it is a line which is passing through the two ends of conic section and also passes through focus. Okay, that is called as double ordinate. Next discussion is latus rectum. So what is latus rectum? It is the double ordinate which is perpendicular to the axis of parabola. So it is the double ordinate. This is latus rectum. It is a double ordinate. Double ordinate's condition is what? That it should pass through focus. And what is latus rectum? It is a double ordinate that is perpendicular to the axis. Clear? So I am drawing it here. If this is your parabola and this is your focus, then the latus rectum is the double ordinate that passes through focus. Okay. So there are two conditions. It should be perpendicular to axis and it should also pass through focus. Such line is called as what? Latus rectum. Okay. And last is focus. As you all know, the fixed point is called as focus. So our next discussion will be on standard parabolas. So there are lot of parabolas possible, right? But we will be discussing standard parabolas in which the vertices will be touching the 0, 0. Okay. So I am repeating it again. The vertices will be touching 0, 0. Such parabolas we will be discussing. Among that, the first standard parabola that I am discussing is y square is equals to 4ax. So let's deep dive into all the information that's present here. If you observe properly, so this is the y axis and this is the x axis. And I am drawing a parabola whose vertex is touching at the coordinate 0, 0. Clear? And this parabola which touches the vertex at 0, 0 passes through the y axis, that is here x axis and y axis. This y is equals to 0, y is equals to 0 is the equation of x axis, right? Y is equals to 0 is the equation of x axis, and here the x axis is passing through focus and is perpendicular to the directrix, right? It is passing through focus and is perpendicular to the directrix. Therefore, this x axis is called as what? This x axis is called as axis of parabola, like we discussed in the previous video. And now also there are some other points that we need to see. This directrix, the equation of directrix is given as x is equals to minus a. Let us see why. See here, the focus that is present is on x axis. So when it is present on x axis and it is opening in the positive direction of x axis, the coordinates of focus are named as a, 0, where a is positive because it is lying on x axis, right? The coordinates which lie on x axis will look like a, 0. Clear? Now if this is a, that is distance from the center to the point, then the point from this point to this line will also be equals to a only by the definition of parabola. Because what does parabola says? That the eccentricity should be equals to 1. When will be the eccentricity equals to 1? When the point to focus, the distance from the point to focus will be equals to the distance from point to the line. Clear? So if this is a, this will also be a only. So if this is equals to a, then this point is minus a, 0, right? Clear? If this is a, this is also equals to a. That is, the distance is a means this coordinate will lie on negative x axis and hence the coordinate will be minus a, 0. Now if this is minus a, 0, then the equation of this directrix will become x is equals to minus a. That's how we write it, right? Because this point is fixed, minus a is fixed, and all the other lines that we are getting on y is 0. Clear? That's why we will get minus a, 0, and hence the directrix equation is x is equals to minus a, which we will write again as x plus a is equals to 0. I hope this is clear. And next thing we need to see is to write the equation of parabola y square is equals to 4ax, we will use the geometrical conditions and derive the particular equation. Now let us see what happens is when I consider point O1 by the definition of parabola, what will happen that this FO1 is equals to O1A1 is equals to O1A1. Why is this happening? Because the ratio FO1 divided by O1A1 was equals to 1, right? It was equals to 1. So if I cross multiply this over here, I will get the equation FO1 is equals to O1A1. Now by using this geometrical condition, what I will do? I will derive the equation of parabola, that is y square is equals to 4ax. Now let us see. See here, this FO1 is equals to O1A1. Now what is FO1? It is the distance between the point O1 and F. How will I obtain the distance between these 2 points? By using distance formula. So this distance formula, by using distance formula, what do we have? Square root of x minus a whole square, x minus a whole square plus y minus 0 whole square, plus y minus 0 whole square. So this was the distance between this point F and O1, clear? Now we need to see O1 A1, that is the distance between these 2 points. How will we see that? Now you can see it is a directrix, that is a line, and this is a point, and the distance between O1 A1 is perpendicular distance, and we have one basic standard formula for distance from a point to a line, that is the perpendicular distance from a point to a line, which is given by, let us say this x1 y1 is any point and this is any line ax plus by plus c is equals to 0, then the distance between this point and the line, that perpendicular distance, is given as this x1 and y1 are put in this x and y respectively, and therefore we will get ax1 plus by1 plus c divided by taking the square root of this a square plus b square in the root, and that is how the distance from the point to the line is obtained. And I will use this same formula here. Now this is the point and this is the line, and we need to see this perpendicular distance, right? And therefore I will calculate this distance by using the point and distance formula, point and line formula. So what I will do, in this equation of line, that is x plus a is equals to 0, in place of x I will put x, therefore I will get x only, and in place of y I need to put y, but here the y coordinate is 0 because we do not have any y here. Can I write this as 0y plus a is equals to 0, clear? So in place of y, if I substitute y also, still it will vanish away because the coefficient of y is 0, therefore I am only getting x here, and lastly I will write plus a, clear? And in denominator I will be writing the coefficients of x square and coefficient of y square in the root. So if I take this under root 1 square plus 0 square with modulus, I will get the distance from the point to line. Now we will solve this particular equation. So what we have, x minus a whole square plus y square is equals to x plus a, under root of 1 is 1 only. Now square on both sides, square on both sides, what do we get? X minus a whole square plus y square is equals to x plus a whole square. And if you solve this more, x square plus a square minus 2xa plus y square will be equals to x square plus a square plus 2xa. Cancel out the things that are getting cancelled, and hence if you just keep this y square here and transfer that 2ax to there, you will get y square is equals to 4x. And that is how the standard equation of parabola is obtained when the parabola is opening towards the positive x axis. And by using the same things, by using the same definition, by using the same geometrical conditions, we can obtain all other equations of parabola, which I will be writing in next slide. Now let us see some different points. Like I said that y square is equals to 4ax is obtained by using the geometrical conditions. Now let us see what is the axis of symmetry. Axis of symmetry was the point which was the line which was passing through the focus and is perpendicular to directrix, and here our axis of symmetry is nothing but our x axis. X axis is our axis of symmetry, clear? X axis is our axis of symmetry, and the equation of x axis is given as y is equals to 0. And next is vertex. Vertex was, it is the intersection of the conic section and directrix. It is the intersection of the conic section and directrix. It is intersecting at the point 0, 0, and hence vertex is here 0, 0. What is focus? The focus for parabola which lies on positive x axis is given as a, 0. And next is equation of directrix. As I have already discussed, this equation of directrix is equals to x is equals to minus a, because it is perpendicular to y axis. When it is perpendicular, it is parallel to y axis. When it is parallel to y axis, then the equation is given as x is equals to minus a, because the distance between center, that is 0, 0 to f is a, then this will also be equals to a only, because that is what the condition for parabola is. The distance between point to focus is equals to the distance between point to the directrix, and therefore this is x is equals to minus a, which will give us x plus a. X plus a is equals to 0 will be the equation for directrix. And now let us discuss the same for another equation of parabola, that is y square is equals to minus 4ax. y square is equals to minus 4ax has some one property that the parabola opens in the negative direction of x axis, and hence the focus will be giving us the coordinates as minus a comma 0, and hence we will write the focus coordinates, that is minus a comma 0. The vertex, that is the intersection between conic section and the axis of parabola, will be 0 comma 0 only. And here also axis of symmetry is again x axis, clear. Axis of symmetry is again x axis. What was axis of symmetry? A line which passes through focus and is perpendicular to directrix, and hence the axis of symmetry here will be again x axis, whose equation is given as y is equals to 0, and equation of directrix, and hence it is parallel to the x axis, but it is lying in the right side. If your distance from here to here is a, then again the distance will be a only, and hence the equation is x is equals to a, which in turn will give you x minus a is equals to 0. And same we will be having other two equations of parabola, that will be x square is equals to 4ay and x square is equals to minus 4ay. We will see in next slide. So, let us see other two equations of parabolas. One is x square is equals to 4ay, which is it will open towards the positive y axis, and see here also the vertex is 0 comma 0, vertex is an intersection of the conic section and the directrix, and let us first write the vertex coordinates, that is 0 comma 0, and since the focus will be on y axis now, the coordinates will be given as 0 comma a, that is very much sure, because now it is in y axis, positive y axis, therefore the coordinates will be 0 comma a. Next, the axis of parabola. If you observe the axis of parabola, here is y axis because it is passing through the focus and is perpendicular to the directrix. It is the line passing through the focus and is perpendicular to the directrix. That line here now is what? Y axis. So, axis of parabola in this case is y axis, whose equation is given as x is equals to 0. And next is equation of directrix. Now, if you observe, this directrix is parallel to x axis. Now, this directrix is parallel to x axis, and the x axis equation is usually given as y is equals to 0, and if this distance is a, this distance will also be equals to a by the definition of parabola, and if this is equals to a, then this coordinate will be minus a, 0 comma minus a, this coordinate will be 0 comma minus a, and if it is 0 comma minus a, here always the y is constant, therefore y is equals to minus a will be the equation of directrix, and hence y is equals to minus a is written as x plus a is equals to 0, that will be the equation of directrix. And similarly, we will see the other case of parabola, this will be the last case of parabola. It says x square is equals to minus 4ay. Here the parabola is opening towards negative y axis, the opening of parabola is in negative y axis, and again axis of parabola is here same y axis, because if you see the axis of parabola here, which is passing through the focus and is perpendicular to the directrix, is y axis. Therefore, the equation of y axis is x is equals to 0, vertex is again 0 comma 0, and focus here is 0 comma minus a, because it is opening in negative y axis, then the coordinates will be 0 comma minus a, and equation of directrix. If you observe, if this is a, this will also be a, and the equation of directrix for this will be equals to y minus a is equals to 0. And here we complete the parabola. Next we will see ellipse. For ellipse, we will be considering two directrix and two foci. I will discuss it later why we do such, but before going to that, let us first see with the help of definition of conic section to construct the definition of ellipse. Now, what will happen? Let us consider one directrix, let this line be L1, and let us consider one focus, let that be F1. Now, if you consider the ratio O1 F1 divided by O1 A1, this is called as eccentricity, the ratio is called as eccentricity. This eccentricity should be less than 1 according to the definition of ellipse. Now, if this has to be less than 1, it means that the distance from this O1 F1 should be less than O1 A1, that is the distance of O1 F1 should be less than the distance between O1 A1. So, if this is small distance and this is larger distance, then only we will get the ellipse. So, if we consider all such points for which this O1 F1 is less than the point O2 A2, that is O2 F1 and O2 A2, and again take any random point on plane, it is following the definition in such a way that the distance between this is less than the distance between this. When you connect all those points together, then you will get an ellipse, clear. and since it is symmetrical towards the x axis and y axis, we will be having two foci and two directrix. The reason behind having two foci and two directrix for this ellipse is very simple. Since the ellipse is symmetrical about x axis and y axis, we will have two foci and two directrix. So, that is how simple it is. And now, the standard equation of the ellipse is x square by a square plus y square by b square is equals to 1. And this is the standard equation of ellipse in which the major axis is x axis. The major axis is x axis, and on the major axis we will be having foci. So, since there are two focus, we will be naming it as foci. The coordinate of this foci is AE, 0 and the coordinate of this foci will be minus AE, 0. These are the points that you need to note. And the next is vertices. Here and here we will be having two vertices. The coordinate of the vertex here is A, 0 and here it will be minus A, 0, clear. And the equation of directrix that is lying here, that is which is parallel to y axis and lying in the right side, will be equals to x is equals to AE, and here which lies in the left side x is equals to minus AE are the equation of directrix. And now if you observe the length of major axis, what is major axis? The major axis is in which the length is very maximum, and here you can see the length is very maximum, and the length of major axis is 2a. Why it is 2a? Because from 0 to a is distance given by a, and from 0 to this point 0 comma a is again given by a. When you add these both distance, you will get 2a, and this y axis is called as minor axis. If x axis is your minor axis, the opposite y axis will be your minor axis. So, these coordinates will be 0 comma b and 0 comma minus b, and if you consider the length of the minor axis, it is given by 2b. Now, if this is b, this is also b, and the total length is given as what? 2b, clear. And when you see the distance between two foci, if you consider the distance between two foci, the distance between two foci is given as 2ae, because the distance is ae and ae, in total it will give you 2ae. Now, it is clear the distance of two foci. The equation of directrix is actually given as x is equals to a by e and x is equals to minus a by e, and then the equation, if it is x is equals to a by e and x is equals to minus a by e, then the distance will be equals to 2 times of a by e, because the distance here is a by e and the same distance will be present here, and hence when you add these both distance, you will obtain 2a by e. And if you have doubt that here we will be having distance as negative of minus a by e, so always distance is calculated as positive. Distance is never negative, it is an scalar quantity. So, it is always positive, since even if the coordinate is minus a by e, the distance will always be considered as a by e only, and here also the distance is considered as a by e only. So, when you add these both, you will be getting 2a by e. I hope this is clear. So, here major axis is x axis, and length of major axis is given as 2a, that is this length is given as 2a. Why 2a? Because the vertices here are named as a, 0 and minus a, 0, then the length will be equals to 2a. Again, length of minor axis will be equals to 2b, and here the minor axis is considered as y axis, and distance between two foci is given as 2ae, and distance between two directrix is given as 2a by e. So, these are some important informations that you need to note, and just like the standard equation x square by a square plus y square by b square is equals to 1, you need to note one thing here, that this always will be greater, that is the value of a square but compared to b square will always be greater. If that is the situation, then you should get in your mind the diagram of this ellipse, that is the major axis lies on x axis and the minor axis lies on y axis. That is something you need to remember whenever you see x square divided by a square, where a square is greater than b square. Then the first thing that should come to your brain is this diagram. Similarly, we have another standard equation of ellipse in which the role of major axis and minor axis will switch. Let us see what it is. Standard equation is given by x square by b square plus y square by a square is equals to 1. Now see here, the major axis is y axis. If the major axis is y axis, then the denominator of y will be greater than the denominator of x square. Clear? Now this number will be greater than this number. If you just see, then you should get to know that whenever in the denominator of y square, if the number is bigger, then this should be the image that should come in your mind. Now the foci will lie on the y axis. Clear? In previously we saw the case where the foci was lying on x axis because x axis was major axis. But here the major axis is y axis now. If the major axis is y axis, then the foci will also lie on y axis, and hence the coordinates of foci are given as 0, AE and 0, minus AE. Okay? And this is the center of ellipse, that is 0, 0. And from minor axis, when you see the minor axis, the x axis is minor axis now, and the coordinates are given as 0, b and 0, minus b. Now if you see all the information, the major axis is y axis here, and the length of major axis is same 2a, and the length of minor axis will be same 2b, and the distance between two foci is again 2ae only, and the distance between two directrix will be 2a by e, and why it is 2a by e? And see, if you now observe, the directrix equation is y is equals to a by e, because this is parallel to x axis. If it is parallel to x axis, the equation of x axis is y is equals to 0, then the equation of directrix will be y is equals to a by e. Clear? And now with all this information, the ellipse topic is completed, and the hyperbola is almost same like an ellipse. All the information is same, but only the diagram will be different because of the conic sections condition. That is the ratio. The eccentricity here should be greater than 1. For ellipse, the eccentricity should be less than 1. For hyperbola, the eccentricity should be greater than 1. So the discussion of hyperbola will be the last discussion. Let us see the standard equation of hyperbola here. X square by a square minus y square by b square is equals to 1. It is same as ellipse only, but only the sign of plus changes with minus. And first thing that you need to observe is here a square is greater than b square. Whenever a square is greater than b square, then the diagram of hyperbola will be this one. That is, here the major axis was the one which we named in ellipse, and we name here it as transverse axis. Transverse axis is just a replacement of major axis. For ellipse we named it as major axis, but for hyperbola we will name it as transverse axis. The transverse axis here is x axis, and on the transverse axis only our foci will be present. Clear? Our transverse axis, on transverse axis only our foci will be present, and all the terminations are same. That is, the coordinates of f1 is a, 0 and coordinates of f2 is minus a, 0, because it is lying on x axis. And if this is transverse axis, then the y axis, then the opposite axis will be named as conjugate axis. Then the opposite axis will be named as conjugate axis. That is the only difference. And here 0, b and 0, minus b will be lying on this conjugate axis, and this 0, b and 0, minus b are called as co-vertex. Okay. And the vertices of x axis will be a, 0 and minus a, 0. Okay. We will write all the information. Transverse axis, here is x axis, here is x axis, and this transverse axis only decides what kind of figure that we will be getting. That is, if in the denominator of x square, if a square is greater than the value of b square, that is, if this number is greater than b square, then this is the opening of hyperbola that we will see. That is, it will be along the x axis. Clear? And the conjugate axis will be y axis here. Clear? This conjugate axis will be y axis, and all the things follow up same. That is, the distance between two vertices is 2a, two foci is 2ae, and two directrix, and here the directrix will come here. These are the equations of directrix. X is equals to ae by a and x is equals to minus ae by e. So these both, the distance between two directrix will be again equals to 2a by e. Clear? All the things are same. We will just write down here distance between two foci is equals to 2ae, distance between two vertices will be equals to 2a, and next is distance between two directrix will be equals to 2a by e. Clear? And one thing that you need to know is this 0, b and 0, minus b are called as co-vertex, and the same follows for another hyperbola in which it will be opening towards the y axis. The opening is in y axis. Here the opening is in towards the x axis. We will see that. This is the another case of hyperbola where the transverse axis now will be your y axis and conjugate axis will be your x axis. Clear? That is the only difference. And if the transverse axis is our y axis, then the foci will also lie on this transverse axis only. Always remember, the foci will lie on transverse axis, and for ellipse the foci will lie on major axis. Here the replacement of names has been done, and hence the foci will lie on transverse axis. If it is lying on y axis, then the coordinates will be 0, AE and 0, minus AE, and the vertices will be 0, A, 0, minus A, and the co-vertices will have the coordinates as minus B, 0 and B, 0 because it is lying on the conjugate axis, that is x axis here. And also if you see the equation of directrix, it is same, y is equals to A by E and y is equals to minus A by E, minus A by E. And one thing that you need to remember here is B square will be greater than A square, that is A square is always, if in the denominator of y square, if you see the greater number in the denominator of y square, if you see the greater number than the number which is lying below the x square, then this is the thing that you should remember. This will be the diagram that will appear. The foci will lie on the y axis here. Okay. What is the clue that we need to remember is the number which is greater. If it is greater in y axis, then the opening will be in y axis. If the number is greater in x axis, then the opening will be in x axis. That is the previous case. Now if you see, the transverse axis here will be, y axis, and the conjugate axis here will be your x axis, and all the distance between two foci is still 2AE, distance between two vertices is still 2A, and distance between two directrix is still 2AE only. And one thing that you need to know here is the eccentricity for the hyperbola should be greater than 1. Clear? The eccentricity for the hyperbola should be greater than 1. That is, if you consider any point, let us say O1, and let if this is F1, when you join these 2 points and these 2 points, that is the directrix 1, let us say this is A1, then O1 F1 divided by O1 A1 should be greater than 1. That is the case for the hyperbola. That is the definition of hyperbola by using the conic sections. In this one video, we have completed the whole chapter conic section. By looking at this video, you will get one proper idea to understand what conic sections are, what circles, parabola, ellipse and hyperbola is. I hope this has helped you. Thank you so much for watching my video. Please like, subscribe. If you have any doubts in the chapter of conic section, do comment. I will reply to all your problems. Thank you.